Section 6 is about making lists or tables, mostly using a function called table. In its simplest form, the table function makes a list with a single element repeated some specified number of times. This input, for example, returns a list with the number 5 repeated 10 times. The first argument in table gives the element, and the second argument gives the number of repetitions. The first argument can be anything. This input, for example, makes a list with x repeated 10 times. This gives a list with 3 identical pie charts. So far, all of these examples have given tables where all of the elements are the same. Tables where the elements are not the same can be made by introducing a variable and iterating over that variable. In this input, for example, the table function makes a result where the variable n goes from 1 to 5. Here, the second argument in table specifies n as the variable, and the 5 indicates that the variable n goes from 1 to 5. The first argument, a of n, in table specifies the elements of the table. To get the first element of the result, the table function sets the value of n to 1, so a of n becomes a of 1. To get the second element, table sets the value of n to 2, and a of n becomes a of 2, and so on. N is called a variable because the value of n varies to make different elements of the list. Here's an example where the first element in table does a simple calculation, adding 1 to n for n ranging from 1 to 10. This makes a table of the first 10 squares. Here's an interesting example that uses both table and range. The elements in the result are the lists returned by range of n for n from 1 to 5. And this gives a result where each list from the range function is shown as a column. This gives a list of plots of the result from range of 10 times n for successively bigger values of n. This gives a list of pie charts with successively more segments. That example uses the table function in 2 places. To see how that works, here is that example without the pie chart function. The inner table function here gives successively longer lists of 1s, and enclosing that table in pie chart causes each list of 1s to be displayed as a pie chart. The variable doesn't have to be the letter n. Here's an example where the variable is called expt, which is a good descriptive name for the variable in this example, which gives the first 10 powers of 2. Here's an example where the variable is x and where x appears several times in the first argument of table. The value of the variable doesn't have to start at 1. For example, this gives a table where n goes from 4 to 10 instead of from 1 to 10. If the starting value is left out, then the value of the variable starts at 1. The variable also doesn't have to increase in steps of 1. This input, for example, gives a table where n starts at 4 and goes up to 10 in steps of 2. The design of the Wolfram language emphasizes consistency, so for example, the range function also provides for changing the starting value and the size of steps between values. This input, for example, works like table and generates numbers from 4 to 10. This uses a third argument in the range function to give numbers from 4 to 10 in steps of 2. As in the table function, if the starting value and the step size are omitted, then the numbers returned by range start at 1 and go in steps of 1. Here's an example where the step size is not an integer. The result here is a table of numbers from 0 to 1 in steps of 0.1. The table function also works this way, so this input also gives a table from 0 to 1 in steps of 0.1. As these examples show, there are usually many ways to do the same thing. For example, this makes a plot of a table of values of x minus x squared for x from 0 to 1. And here's another way to get the same result using range rather than table. In this input, the first use of range gives a list like the table of values of x for x from 0 to 1 in steps of 0.02. The second use of range gives the square of that table, and subtracting those two lists gives the same plot as before. It is sometimes important to keep in mind that the table function separately computes each element in the table. To show what is meant by that, here's an input that gives a list of 20 random integers, so each element in the result is a randomly selected integer between 0 and 10. The point to notice here is that this input does not generate one random integer and then return a list with 20 copies of that same integer. The table function instead calculates a value for a random integer of 10 separately for each element in the list, so the result is a list of 20 separately generated random integers. The random integer function can actually generate a list of random integers all by itself using the second argument in random integer. For example, this input also gives a list of 20 random integers between 0 and 10 by including 20 as the second argument in random integer. If that second argument is omitted, then the random integer function just generates one random integer. That's the end of the examples for this section. Here is the programming vocabulary for this section. The main topic of this section is different ways of using the table function, or more specifically, different forms for the second argument in the table function, including the use of a variable and inputs for specifying a starting value, an ending value, and the step size for values of the variable. Also in this section were examples showing how these ways of specifying ranges and step size are used in other functions, such as the range function. One convenient way to get more information about functions like table is by simply entering $table. For example, the display from $table shows all of the different uses of the table function that came up in this section. There are also several relevant guide pages that can be accessed from the Wolfram Language and System Documentation Center. For example, clicking Core Language Instructor and choosing Lists from the menu that pops up brings up this guide page with links to documentation for table and range and related functions. Here are the exercises from the end of this section. Many of these exercises involve a review of vocabulary from previous sections. For example, exercise 6.6, make a bar chart of the first 10 squares, involves making bar charts, which was a topic from section 4. A table of the first 10 squares can be generated using table of n squared for n going up to 10. To make a bar chart, just enclose that input in the bar chart function. As shown in the examples, the same list of squares and the same bar chart can also be generated using range rather than table.